Hi everybody. So my main focus of the webinar today is going to be talking about the testing requirement within the protocol as a little bit of an introduction to SoilEx. As a business, we work predominantly within the construction and demolition sector, but also utility and highway sector around management of excavated wastes. That involves consultancy, testing, and then onward movement of wastes, specifically contaminated waste will be one of our specialities. From a Streetworks UK perspective, we're an affiliate member. We have been involved with several rounds of the trials that underwent in the last couple of years to lead to the point where this protocol has been developed. And that included us going out to utility sites, taking samples, putting them into the lab, assessing them and reporting them. So we're quite well placed to provide some context as to some of the challenges, some of the opportunities, and just some of the considerations that all of your businesses are going to need to have with regards to the testing element of the protocol. We are obviously working with quite a lot of the contractors already as well in regards to getting their plans in place for the 1st of October, and that's provided a really good insight for us as a business who aren't a contractor, aren't a utility contractor, as to some of your challenges and some of the ways that each individual company are taking on that challenge. So hopefully we can provide some decent information, but also some opinions on some of the best ways to move forward. So what we're going to cover today is what the testing requirements are of the protocol, which hopefully a lot of you are already on board with, but just to reiterate that, some of the on-site testing parts of the risk assessment, the sampling and testing requirements, any potential contamination risks, what actually then assessing the data means, and then things around getting a good correlation between the risk assessment and the testing. Some other challenges which are slightly outside of the protocol but that we've been talking about before that I actually have been asked to include by a couple of people, so there'll be a very quick overview of some other challenges that I think are worth considering, which might be an offline conversation, and then there's a Q&A at the end, if time permits. So what are the testing requirements of the protocol? So as a very brief plotted history, since 2018, I believe there's been a position statement in place that essentially has allowed a lot of utility waste to go untested via a lab to allow it to be classified. And then there's been a couple of, I think 3 rounds of trials, which has been essentially providing a correlation between a risk assessment based approach to classification of waste and lab data, which, like I said, we've been involved in before. And we are now at a point where, as of the 1st of October, when the protocol comes in, that to provide the Environment Agency with some confidence that the risk assessment-based approach is working, that 1% of the excavations that are conducted need to be sampled, and then the waste analysed via a lab and then classified and then compared to that risk assessment. So as it's starting on 1st of October, you're looking at Q4 of 2025, and the sampling numbers that each business needs to do is based on the excavation numbers from 2 years prior. So if you look at what the requirement is for Q4 2025, that is based on your 2023 numbers but prorated for the last 3 months, and then your 2026 excavation numbers are based on 2024 excavations. So as a guide, if you are doing 1,000 excavations a year, you would need to sample from 10 excavations per year and then analyse those. Each excavation won't necessarily always be one sample. You'll need to sample the waste that are generated from that excavation. So often it might be an asphalt layer and then a sub-base layer, or alternatively it might be a grass verge, in which case you would only be likely to be taking one soil sample from that excavation. So The excavation numbers don't directly correlate with your sample numbers. They will change depending on the nature of works you do and the sites that you choose to sample from. So why are we testing utility waste? And essentially what it is to provide evidence that the risk assessment approach works. I was just saying to Clive slightly earlier that we work across the construction and demolition sector, and they aren't in a fortunate enough position that they have a risk assessment based approach to classification. They have to follow the guidance that says that all waste needs to be tested. Due to the nature of the utility works, obviously that isn't always possible, but the risk assessment approach shouldn't be, and the approval of it should not be taken lightly, because without it, testing would be extremely expensive and obviously would be very detrimental to the work that the utility contractors are doing. So making sure that the 1% is done, I know is hugely important to Streetworks UK and to all the work that they've done. And it has got to be reported to the Environment Agency. So people, if they're not hitting that 1% number, or they're not providing that information as they should be, is going to have a real detrimental impact onto all the work that has gone on to date to allow utility contractors to be into this position. And that correlation of the risk assessment versus the actual lab data is going to be a real guiding factor as things move forward and as things develop. So I've taken this from the Streetworks UK page. I don't know how well that correlates across the screen, but you can get this from the Streetworks UK website, and it looks at the timelines for what needs to be done by contractors, then subsequently Streetworks UK and the Environment Agency. So you can see right at the top there, the testing starts in earnest from October the 1st, or essentially Q4 2025, at which point results need to be submitted and sent across by the end of Q1. They then going to get assessed by the Environment Agency, and that's and then conversations will be had between Streetworks UK about how that's working. Again, these are taken from the protocol document itself, but there's a real consideration for contractors around quality of data and accuracy of performance. So what is going to be monitored is how good the correlation is between the data. If the correlation is low, that is going to affect, or lower than hoped, then that is going to affect sampling numbers for contractors going forward, and looking at the timeline, that's going to be assessed at the end of 2026. So you can see here in the bottom right-hand corner of the screen, there is a correlation for ongoing testing percentage for ongoing testing based on the accuracy of your correlation. So if you are running, say for instance, 100 excavations and sampling from 100 excavations per year, and you're getting over a 93% accuracy and correlation between your risk assessment and your lab data, your ongoing testing will remain at the 1% of excavations. However, if it drops between 85 and 92.99, essentially the amount of testing you're going to have to do will double, and if it drops below 85, it's going to treble. So not only is that obviously going to be a hindrance to the business in terms of how much work, the ongoing work you have to do, it's also going to be very, very expensive. So a lot of the people that we've been talking to now is all about how to get that accurate data, quality risk assessments done, proper samples assessed properly, so that correlation is as high as possible for your business. And this is some of the things I'm going to talk about today, just things to consider as you develop your plans to how you're going to sample the waste. Also, this is again from the protocol, the use of the protocol ongoing for businesses is going to still be affected and could be affected by that correlation. So a drop in correlation below 70%, I think for 2 combined quarters, will mean that the use of the protocol is suspended for your business. Now, as I'm sure you know, that would be catastrophic in terms of having to then ultimately test every single excavation that you take, which isn't feasible. So getting it right early on is going to be really, really important. So within the protocol and within the site-based risk assessment itself, there are two forms of on-site rapid testing or quick check methods that are not mandatory, but provide as an option to help with that risk assessment and help with getting a good correlation. One of those is pack spray, which I'm sure is widely used anyway, but pack spray and asphalt to assess the likelihood or not of coal tar. The other is litmus paper to determine pH levels within the soil. Again, these aren't mandatory, but what they might do is allow you to get a better correlation with what ultimately comes back in the lab data. So this is taken from the protocol around litmus testing. Now, as a business, I'll be honest, we don't do litmus paper testing, so this isn't something I have a huge amount of expertise on, but ultimately what it's there to do is to assess the levels of pH in soil samples. So you wouldn't be doing litmus paper testing on asphalt, and you can see the colour chart down the side there, which is going to provide you with whether the results are classed as contaminated or red, or positive, or negative, and that would allow then, if you're getting that and you're putting your risk assessment, that would be ultimately how you're classifying and onwardly moving your waste. With pack spray, again, pack spraying the asphalt to look for discoloration is going to give a really, really good guide on the likelihood of coal tar being present within that asphalt, and there's some simple steps and guides to there, and then some colour charts for you to compare it to. Now, we as a business are going to be going out and we're going to be doing a lot of sampling ourselves for a lot of clients. And again, this is just an idea that we've had that might help with some of your site teams to aid in this process. So we have designed a sampling board. So when our engineers go to site and do pack spraying, they would have this board with them. It would allow them to make note of the date and all of the permit and excavation they're at and the address. It provides them with instructions as what to do, but it also allows them to pack spray, put it on this white surface, do a colour comparison, take some photographs so you can evidence your process, you can evidence the colours change on the pack spray if there is any, and it will just, I think, mean that your on-site teams, who we appreciate will have a lot of different jobs to do, are provided with a real simple and clear way to determine if they are following the protocol directly. So as a guide, it would look like this on site. Now, that's a different board that we use, but this is just for context, really. But by providing some simple tools like that to your site teams is going to mean that they're going to be able to assess that waste more accurately and likely get a better correlation between the lab sample and between the risk assessment. So what needs to be sampled and tested in a lab? So there's essentially three different waste streams that have been specified within the protocol. One being asphalt, the blacktop layer from an excavation, and that is specifically looking at the likelihood presence of coal tar. So the testing suite specified, which is in the protocol, is predominantly based around hydrocarbons, and then looking, so a PAH double plot ratio, which is specified in the protocol. Essentially what that looks at is the PAH results, and then it's plotting the likely source of that contamination. So you might have elevated hydrocarbons, but it might not have come from coal tar, but it might have come from something else, like a fuel spill, for instance. And that double plot ratio needs to be done as part of the assessment. Then you have got the two soil samples. So essentially they are being classed as made ground and soft ground. So made ground would be any soils, sub-base layers, etc., that have got anything other than soil in them. So it could be an aggregate, it could be demolition waste, it could be rubbish, who knows what's been put in the ground. And this is where there is a higher chance of contamination being present than in soft ground, which would be predominantly naturally occurring soils. The testing suites for the both are very, very similar. The only difference is the analysis for asbestos in a made ground sample, because asbestos is very, very unlikely to be present in a soft ground sample, but asbestos fibres, which are essentially invisible, very likely to be present in made ground. And if you do find asbestos, you have to quantify it. There are also some other contaminants that are optional to look at, and that would be based on visual assessment. So, for instance, VOCs, SVOCs, which measure volatile organic carbon, that would predominantly be present if there are hydrocarbons in the ground. So it might be that if you are taking a sample from a site where there are hydrocarbon staining or odour, that you might submit some samples for some additional analysis. But that's a professional judgment, and ultimately needs to be driven by somebody that knows what they're looking for and understands the testing process. So one of the main considerations for taking soil samples or taking waste samples and then putting them into a lab is quality of sample to get compliant, accredited and accurate results. And so what we'll talk about here is just quite a few of the considerations around essentially what is getting some soil or some asphalt into some tubs and jars and getting into a lab. But whilst that sounds simple, there are a lot of stumbling blocks and a lot of things that could throw results out. So we'll talk about quite a few of those here. So the waste sampling technique, especially in regards to soils, and this is specified within the protocol, is to take an appropriate composite sample. So in the world of, utilities, what that would mean is so firstly you have to sample from a stockpile. So we're not taking samples from the excavation itself, you're taking it from a stockpile next to the excavation. But a composite sample in our world, and how we would advise to take it, is the engineer would have a clean bucket and a clean trowel, and they would be taking multiple scoops. The minimum of 3 is specified in the protocol, but multiple scoops from around the stockpile itself, not just one specific area. It goes into the bucket, it gets mixed up, and then it gets placed into the sampling containers, which are tubs and jars, which I'll talk about in a minute. What this is doing is it's giving you a much better view of the waste stream as a whole, and it's also likely to mean that you're not getting very, very concentrated results from a very, very small section of a stockpile. So a sample that has to go to the lab is very, very small quantities in compared to the overall waste stream. So what we're trying to do here is get as reflective result as possible to represent that whole waste stream. So therefore you do have to sample from the whole way around that stockpile, get a good mix, get a good inclusion of everything that's involved, so that you are getting representative results. So other few things to consider is you don't want to include too many large inclusions in your sample. A lab will typically screen out anything above about 10 millimetres and not include it in the sample. So it might mean if you're including large amounts of stone, not much soil in a soil sample, there ultimately isn't enough sample to test. So you want to make sure that your sampling process isn't including lots and lots of big stones and things like that, because it could throw results out or just mean that you get deviating results through lack of sample volume. So you've got to use the correct sample containers. This is really important because if you're not using correct sample containers, what it ultimately might mean is that your results, when they come back from the lab, either you don't get them back at all because the lab might say, no, they're unaccredited results, I won't test them, or what it might mean is that your results come back as deviating. And what that ultimately means is that when they are assessed down the line, the environment agency might look at that and go, yes, you've got lots of test results, but ultimately none of them actually have been done correctly, and either they'll be discarded, discounted, or it might make some conversations around poor correlation more difficult. So you have to make sure you're using the right sample containers. The protocol specifies for soils 2 tubs and 2 jars, as you can see on the right hand side here. Asphalt typically just needs 2 jars, but what I also say is whatever lab you're using, whatever supplier you're using, speak to them as well, because they will have their own processes which are guided by UCAS and MCERT's accreditations for the soil sample volumes that they need. But ultimately it's very, very important that both the tubs and the jars are used, because they're used for different analysis in a lab and it will affect some of the results. So the tubs, for instance, are used for things like metals contamination, an asbestos analysis, whereas the jars, the amber vials and jars, are used for hydrocarbons. Reason being, hydrocarbons can be affected by sunlight, and so therefore the amber jars mitigate some of that risk. And you also want to make sure you're doing, when you're filling up those jars, is you're filling them right to the top. So part of the accreditation is that there should be no headspace left in those jars, because what it can do ultimately is it can reduce some levels of contamination that are shown when it gets to the lab. And again, that might end up with a deviating result or with a lab not testing it at all. Finally, what you want to make sure is those tubs and jars are labelled correctly. So very important is a sampling date, and the sampling date I'll come on to in a little bit later. But also making sure you're writing your excavation number, your permit number down, name of engineer that took it, because as you can imagine, labs receive thousands of soil samples every single day. They're going to receive even more post 1st of October. If they aren't labelled correctly, what it might mean is that all of the sampling you're doing goes to a lab, and they can't process them because they don't know where they've come from. So having clear labelling is very, very important, hence why we put our own design stickers on there, because those stickers will guide the correct information that needs to go onto the tubs and jars. The tubs typically come without any stickers on at all, even from the lab, so that might mean that it's not guiding your site teams or whoever's taking the samples as well as they need to. The transportation of samples is also very, very important. Accreditations with labs dictate that soil samples and asphalt samples do need to be temperature controlled. They need to make sure that soil samples aren't affected by direct sunlight. You need to have ice packs, cool packs, or cool blocks in however you're transporting your soil samples and your asphalt samples as well. Again, if they turn up to a lab without that, the lab is very likely to provide a deviation on your results, which can mean that the results aren't valid. It also does help you keep the samples together. You know, you're going to have a lot of tubs, a lot of jars kicking around in the back of vans, and you want to make sure that they're all kept together, and so that they're ultimately able to be sent off and tested at a lab. So most labs will provide cool boxes, the blue boxes you can see on the left-hand side there. You also can use, and we do use, cardboard boxes as long as there is a cool pack in them. We've worked with our lab to allow them to provide accredited results with samples that are sent via a cardboard box, because ultimately it's still temperature controlled with a cool box, cool block or cool pack, and it's still protected from direct sunlight. All of the samples that are sent to a lab must go with a chain of custody, which can either be included in the box or emailed over, and ultimately this is going to provide the lab with all of the information they require in terms of permit numbers, excavation numbers, any references, any postcodes, or all, you know, ultimately the information that ends up on that lab data result that is emailed and sent to you all comes from this chain of custody. Sampling date, very, very important, because sampling date will correlate with how long it takes to get the samples to the lab, and again that can have an effect on accreditation and deviation of results. And it will also tell you what you want it to be sampled for. So you can see the columns on the right hand side there have got either the bituminous suite, the soft ground suite, or the made ground suite. So if you send off your samples to a lab and you aren't specific on what they want and what they need, they're not going to test. And ultimately it might mean that you've wasted your time to get all those samples to them. So important that you do a chain of custody. One of the ideas that we have is, you know, this is a standard form that the labs provide, because you're only ever going to be doing one of 3 different suites, you could really create a simplified version of this chain of custody, which your site teams could quite easily fill out with a simple few tick boxes. So it wouldn't necessarily need to be as complex as what this chain of custody looks like, and again that could simplify a process. You need to make sure you get your samples to the lab on time. Nearly all labs will provide a courier service, which essentially is free of charge and comes with the testing, but you can't let those samples sit there for weeks on end before you send them off to the lab, because there are specific holding times that the labs need to work to, and that correlates back to the sampling date. Now, that does change depending on what contaminants are being tested. For instance, asbestos in soils, you could hold for an indefinite amount of time, and you'd still get accredited results. But things like hydrocarbons, which are likely to change over time, I think it's around 7 days that you have. So you would need to make sure you've got a process for sampling and that collection and getting those samples to the labs in an orderly time. Otherwise, again, you might end up with results which are deviating. So accurate sampling means accurate results, and I think there's a few things that can adversely affect results, and these are some of the things that we consider when we're going out to site and taking waste samples. So one of the things that has to be analysed for is pH levels. Now typically pH in soil is non-hazardous. We very, very rarely see alkaline or acidic results in soils. However, that can be thrown out. So if you're taking a soil sample and you're including concrete in it or cement products in it that go to a lab, the way the lab then treats that soil sample is they dry it out, they crush it down essentially to a powder, and that allows them to put it through their machines for analysis. But the process of crushing down concrete or cement will likely give you a pH spike in your results. Now, that would mean ultimately that you'd look at a waste on site, you might risk assess it and say, well, that doesn't look contaminated, there's no risks of it. You might even do the litmus paper test on the soil and it comes back as being negative. But if you include concrete in your sample that goes to a lab, you might end up with a positive or a spike and an elevated pH result, which ultimately would mean that the classification would be a red, whereas you've site assessed as green. That gives a poor correlation and will affect your chances of hitting the 93% that you want to hit. What's also useful if you are taking soil samples, especially when you're considering the likelihood of a concrete affecting it, is take photos of the samples that you're taking. Because sometimes what you might be able to do is, even if you do get an elevated result, whoever's assessing the results for you might take into account that there was concrete in the sample, and that might allow them to reclassify that waste depending on other information and parameters as being non-hazardous anyway. So photos are really, really important. Asphalt in a soil sample. So obviously there's a requirement for all contractors now to segregate waste streams on a site, so asphalt should be kept separate from soil, but I think it's inevitable that cross-contamination will happen. It's almost impossible to fully segregate everything just because of the nature of work and the nature of the ground. But it's really, really important that asphalt fragments aren't included in a soil sample because they will likely affect hydrocarbon levels. It's very difficult when you get the results to fully determine that those hydrocarbon increase levels have been caused by asphalt. And again, it might mean that where a site assessment has shown it to be green, you might end up with a hazardous result, albeit in real terms the waste probably isn't likely to be hazardous, but because of the inclusions of the asphalt that might affect the results. So I would, whoever's taking that sample needs to be really vigilant on excluding wherever possible any asphalt from that soil sample, and specifically given that the amber jars are the ones that are assessed for hydrocarbons in the lab, make sure as a minimum you aren't putting asphalt within the soil samples into the amber tubs and jars, because that is what you get your hydrocarbon results from. Now I know that asbestos or asbestos fragments being present in an excavation excludes it from a risk assessment process. However, it's still, I think, worth mentioning that asbestos is still one of the contaminants that is required to be assessed within the made ground suite of analysis. And if there are fragments or small fragments present in the ground and they do find their way into a soil sample, that is going to affect the results, obviously, but also the key parameter when you're assessing asbestos is the percentage within that soil sample, with 0.1 being the key difference between a hazardous and a non-hazardous result, or a visible fragment being present. So as a minimum, you want to have no samples going from an asbestos impacted site anyway, but just make sure whoever is taking those samples that they are taking into account that asbestos is still analysed within the suite, and you want to make sure that no asbestos fragments or visible fragments are finding their way into the samples. So coal tar and asphalt. So our knowledge of the industry and the work that we do across lots of construction sites tells us that I think coal tar and asphalt is far more prevalent than a lot of people think, and probably far more prevalent than maybe some of the waste is being managed from the utility sector previously. So there's a bit of history. Any road that is laid pre-1990 or very late 80s has got quite a high chance of coal tar being present within the binder to some level. And even if your roads have been resurfaced or relaid, some of the deeper layers of asphalt are still likely to have coal tar present within them. The pack spray will provide a really, really good indication as to the likelihood of coal tar being present, but as will the appearance. So coal tar often has quite a distinct odour. It has a sticky appearance, as you can see a really good example of that picture there on the right-hand side. And site history, look around when the age of the houses, the age of the roads and all that kind of stuff that might give you an indication that coal tar is to be present. Because if the risk assessment process just carte blanche classifies everything as green from an asphalt perspective, it will likely mean you're going to get a poor correlation because, like I said before, coal tar is prevalent and is a real contaminant of concern, and in my opinion is likely to be the one that throws out correlations more so than any other contamination in the ground. So it's one to be very, very wary of. And I think provide good training to people completing your risk assessments as to what to look out for, not just pack spray, but other signs, like I've mentioned, that might indicate that coal tar is present. So hydrocarbon contamination, so this obviously is part of the risk assessment to look for evidence of, whether it be an odour, whether it be hydrocarbon staining, and if you are seeing that in an excavation, then what that ultimately will mean, that risk assessment shows that waste to be red, and therefore needs to be treated as hazardous. So ultimately what we want to happen then is that you want your results to correlate with that. So where you are seeing hydrocarbon staining and hydrocarbon odour, it is likely that hydrocarbon contamination is present. So taking a sample that represents that is really, really important. If you have some hydrocarbon staining, but ultimately you take a soil sample from 4 metres down the road from some soils that look absolutely fine, you're going to get a poor correlation because it will likely mean your results come back as being uncontaminated. So it's just making sure that the waste you are taking for analysis from your testing is representative of how you're assessing it in the risk assessment. So those hydrocarbon impacted soils need to go into your composite sample, and you need to make sure that they're then that hydrocarbon impacted soil is finding its way into those amber jars, because that is what you're going to give your hydrocarbon results. You want to make sure you're not keeping them in the sunlight. You want to make sure you're not leaving loads of headspace in those jars, because again, that can dissipate the hydrocarbon levels over time, and you could end up with results which either are deviating from the lab or aren't actually representative of the waste that's happened. And ultimately what we're here for is to get a good correlation. So one of the big challenges is heavy metal contamination. There's no questions in the risk assessment regarding this, but ultimately because most of the time, almost invariably, it's an invisible contaminant. You will not see signs of metals contaminations in soil. But there are things you can do. So the way that heavy metals behave or are present in soils is they sit in pockets. They typically aren't mobile like a hydrocarbon would be that can leach through soils. So because of that, if you are able to take a proper composite sample, take lots of scoops from around your stockpile, mix the waste well before putting it into those tubs and jars, it will mean that you are likely to get as representative result as possible, rather than a spike caused by taking a soil sample from a very specific place in that stockpile, which might, if you're unlucky, be an area impacted by metals. And just one other consideration which came up last week with someone we were speaking to is there are some areas of the country who have a historical issue with metal contamination in the ground, either naturally occurring or through what's happened in industry previously in those areas. And if you're working in a specific region, it's worth speaking to somebody that knows what they're talking about just to figure out if that is a likely issue for you. Now, whilst I think that's going to be challenging to get to affect from a correlation perspective between risk assessment and an actual lab result, it might be worth flagging now so that ultimately onward conversations with Streetworks UK and the Environment Agency can be headed off. So we've talked about collecting samples, we've talked about sending things to the lab, and we've talked about getting results back, but one of the really, really important parts of this is actually then assessing those results. Most labs, not all labs, every lab works differently, but most labs don't actually do the assessment themselves. They will be sending you a set of data, which will be a big table with a lot of numbers, and that will be it. And then there is a process that was required to actually then assess that data in line with technical guidance WM3, which determines whether your waste is either hazardous or non-hazardous, or in the instance of the risk assessment, red or green. And it isn't a simple and straightforward process at all. You need to have someone who knows what they're doing that. Because again, data can be assessed differently by different people, and you want to make sure yours is as accurate as possible. So there's things that that can be taken into account when you're assessing and providing a classification, such as moisture content, the physicality of any asbestos that's present in the waste, metal species. So one of the without going into too much technical detail, some of the parameters that are included in that made ground and soil suite are metals. But when you're assessing metals, you aren't just assessing it against you have to choose a species. You aren't assessing it against a single species of metal, and that all takes into account from site history and other kind of behaviours of certain metal species. So it isn't quite as simple as assessing your results against a standard set of data. Source of hydrocarbon contamination can also be considered when you're assessing and classifying a lab result. So there's a lot to consider there, and there's a very, very simple guide. We use the Haz Waste and Line classification tool, which hopefully you can all see a slide of there on the right hand side. And for demonstration purposes only, what I've done is I've input a hydrocarbon result of 1,000 milligrams per kilogram on the right hand side, and then at the top what I've done is I've changed whether you are factoring in moisture or not factoring in moisture content in your soil sample from a classification perspective. So you can see on the left hand side here you have a result of 1,000 milligrams per kilogram. No moisture correction has been taken into account. So essentially what you're doing there is you're assessing the moisture levels within the soil sample, and that needs to be taken into account when classifying waste. If you don't take it into account, this result here is gone red, which means it's classified as hazardous. Whereas on the right hand side, we are taking into account moisture, which is the right way to do it, and it's been classified as non-hazardous. So a very, very simple demonstration around how incorrect assessment of results, even if you've done all of your processes before well, incorrect assessment of results could mean incorrect reporting and ultimately then a poor correlation as well. So make sure within your processes, in your businesses, you are getting people that do know what they're doing to assess the results in the right way. And just finally, a couple of other bits that, before we come on to the Q&A, that we've been speaking to some people about. So one of the challenges here ongoing from the 1st of October is going to be around the management of hazardous waste. So it is a fact that there are far less permitted hazardous waste facilities in the country than there are non-haz permitted facilities, which means that the options for removal of that waste are limited, especially if you're moving very, very low volumes from each excavation. What you don't want to do is travelling 50 to 100 miles with half a tonne of asphalt on your back. So identifying appropriate outlets for your business is really, really important. Almost no waste should be going to landfill. So from a sustainability and a cost perspective, there are treatment options for almost all types of contamination you're likely to find in your waste from utility excavations. But also there's other opportunities to look at, say, temporary storage of hazardous waste prior to it being moved to its final treatment or landfill destination, which ultimately could mean that you can bulk your waste together, reduce the number of lorry movements that have to go a long way. There's obviously some compliance things that need to be put in place and some processes that need to be put in place for that. But if you are, one of your challenges is movement of hazardous waste and not quite sure what to do with it, which I know, having had a conversation with someone last week, that is one of their issues. There are ways around it. I can talk to you offline about that, just in terms of what you might be able to do, set up with your supply chain to help that and to mitigate quite a lot of the cost and logistical challenges around that. And then just finally, touching on WM3. So obviously the protocol, as most will know, applies to certain permitted works, but doesn't apply to works under a major permit unless it's for traffic management purposes. So what does WM3 say? WM3 being technical guidance, what does that say about what you have to do in terms of classifying waste that doesn't fall under the protocol? Well, firstly, you have to assess, like we're doing with all the other testing, all of your excavations, all your waste will be what's classed as a mirror code, which means it can either be hazardous or non-hazardous waste, and you have to assess it to determine if it's hazardous or non-hazardous. That will involve chemical analysis, identifying what your potential contaminants are, doing the assessment like I've just talked about, and then doing a full classification piece. WM3, and we've highlighted it in yellow there, specifically says where it genuinely cannot be tested for any reason, you must then classify that waste as being hazardous, which obviously would be very, very expensive for your business. So having a proper WM3 strategy, which isn't necessarily part of this protocol, but is affected by the protocol, is really important for any work that isn't falling under major permits. And that's pretty much all of my slides. Hopefully it was useful and clear, and we've got a little bit of time for Q&A.